Hello, welcome back. As of today, we are going to proceed with electronics, and the part we're going to discuss today is rectification. Rectification is possible because of the characteristics of a diode. Diode can be used as a rectifier. Diode as a rectifier. First of all, we have to know what is rectification. Rectification can be defined as a process of converting an alternating current into a direct current. Alternating current is what we call an AC, and direct current is what we call a DC. Now, a diode can be used to perform that task because a diode has a property which is known as biasing. It can only be connected in a specific direction. Therefore, we use a diode as a rectifier because of its property of having a reverse bias property and a forward biasing property. Electrification is divided into two types. There are two types of rectification. The first one is a half-wave rectification, and also there is a full-wave rectification. So we are going to discuss in length about these two types of rectification. We are going to start with half-wave rectification. Now, as we say, rectification is converting AC current into a DC current. We are doing that because AC current is normally not used in many of electronic devices. Only a direct current is used in electronic devices. That's why we have to convert an AC current, which is normally in that way because it is easy to transfer from a production site to the consumption site. So we are going to start with half-wave rectification. Half-wave rectification is achieved by using only one diode. Why we call it half-wave rectification? It is because only one half of a cycle of an AC current is used in this conversion. And half-wave rectification, it is achieved by using a single diode. It is achieved by using a single diode, which in case conducts current during a positive half cycle only. It conducts current during a positive half cycle only. Why? Because a diode, this side is positive, this side is negative. Now, when it is connected to AC, it means that since AC changes polarity with time, at certain time it is positive, at certain time it is negative. During a positive cycle, this diode will be forward biased. Now, we know that a diode conducts when it is in forward bias. So during a positive half cycle, the current will flow. But during a negative half cycle, it's the same diode. But during a negative cycle, this will be connected to a negative terminal, to a negative side, and this will be connected to positive side. And then this means that it will be reverse biased. Now, if it is reverse biased, this means that there will be no current flowing in this side. Therefore, this diode will conduct only during a positive half cycle. Now, since one cycle is not conducted, that's why we call it a half-wave rectification. So we are going to see a circuit of half-wave rectification. So, on proceeding on half-wave rectification, let us consider the following circuit diagram. Now, this is a simple circuit which shows a half-wave rectification action. We're going to start with, this is a diagram which shows a simple circuit for half-wave rectification. On this side, we have an input. The input is AC. That's why it is alternating on the positive side and on the negative side. It is changing its polarity with time. That's why it is known as alternating current, alternating voltage. Now it is changing with time. So it is going like this one. This is the positive half cycle, and the downward, it is the negative half cycle. It is connected here on the terminals of a transformer. So it is connected here on a terminal of a transformer. With time, this can be positive and this will become negative. But on another time, this will become a positive and this will be a negative. Now, these actions of changing polarity is what give out the following, we call it a sinusoidal waveform. A sinusoidal waveform of AC current, alternating current. Therefore, on half-wave rectification, the following happens. During a positive half cycle of an alternating current, the point A become positive. When this point A become positive, point B become negative. Now this is positive and this is negative. The current from this transformer give out these poles. This is positive, this is negative. Now if this is positive, we know that here there is a diode, a single diode which is connected in this circuit. On this diode, we know that this side it is positive and this is negative. This means that diode D1, it is forward biased, since a positive terminal of the diode is connected to a positive side and the negative terminal is connected to a negative one, a negative side. This makes a current to flow. The current flows and comes to a load resistor here. And then returning back to the what? To the transformer. This is during the half cycle, the positive half cycle. The first half cycle of alternating current. Now, during a second half cycle, which is a negative half cycle, the point B become positive, while point A become negative. Now, this is during the second half cycle. Now, if this is negative, and we know that this is a positive terminal, it is an anode of a diode. It means that this will become reverse biased. Now, when it is reverse biased, it means no current will flow to this load resistor. Now, when there's no current flows, it means there will be no current in the load resistor out there. So this means that this diode will only conduct, or there will be a flow of current during a positive half cycle only, giving a sinusoidal waveform of this form, having a current flow during a positive half cycle and no current during a negative half cycle, having a current flow during a positive half cycle. Now, since only one half of a positive, since only one half of alternating current is used in this conversion or in this flow of current, this is what you call a half-wave rectification. So during a positive half cycle, A is positive with respect to B, hence a diode is forward biased. Since it is forward biased, it will conduct. Now during a second or a negative half cycle, B will become positive and A will become negative, hence it will be reverse biased. On reverse bias, there will be no current flowing to the load resistor and back to the resistor. Therefore, a diode conducted during a half cycle only on the input, and hence a half-wave rectification. Thank you for watching. We'll proceed with full-wave rectification on the next lesson.